Welcome you all. In this video, we are going to discuss about NACA numbering system for an aerofoil. Myself, S. Karthikeyan, working as a faculty in the Department of Aerospace Engineering at B.S. Abdul Rahman Crescent Institute of Science and Technology, Chennai. This video is going to cover basically three main topics. The first topic will be aerofoil nomenclature, and second topic NACA numbering system with full description. Nearly 7 or 8 type of systems will be available. We are going to discuss one by one. And last topic, you may have some doubt. This type of aerofoil will be available. How I can choose my aerofoil for designing airplane or some theoretical point of view. How I can choose my aerofoil. Some hints also will be given for the end of this presentation. So these are topic we are going to discuss one by one. So before starting with the topic, I want to make you clear about some basic questions. The first question, what is NACA series? So NACA series is nothing but the numbering system of an aerofoil. So many types of aerofoil will be available. We want to identify the aerofoil. That is why the NACA numbering systems are developed. So NACA is nothing but the expansion of NACA is National Advisory Committee for Aeronautics. So it is a US based federal agency, so founded on March 3, 1915. The main aim of this NACA committee to do the research based on the wind tunnel. They have done so many research based on the wind tunnel, and when they are doing the research based on the aerofoil, okay, they find so many similarities for the aerofoils. Okay, in the early 1930, they produced one report. It's a very famous report. The name of the report is the characteristics of 78 related aerofoil section from testing the variable density wind tunnel. Okay, so this test will be given the relation between the aerofoils. Okay, that is why they have started to numbering the aerofoil. This is the initial stage to develop the aerofoil numbering systems. They started in the early 1930. In the year of 1958, okay, the NACA officially turned over operation to NASA because they want to develop the research in all the areas. That is why they turned the operation over to NASA. So the NASA having ability of do the research in both atmosphere, space and land level. So that is why they are turned over operation to NASA. So this is just a basic idea about NACA. You may have another question. So why should I know about aerofoil nomenclature? Because we want to design the aerofoil, you must know some basic idea. So what are the basic ideas? The structure of the aerofoil, some data. Okay, so whenever you are having the idea to design the aerofoil, it depends upon the some factors. So what are the factors? The two primary variables that affect the shape of an aerofoil. The first variable will be the slope of an aerofoil mean camber line. The second will be thickness distribution above and below the line. Okay, so for this I want to come to know what is the meaning of the camber line. So these are the data we will be come to know at the end of the study of the aerofoil nomenclature. So that is the need of to study the aerofoil nomenclature. And third question, suppose I want to identify the particular point in the aerofoil, or I want to generate the total aerofoil coordinates. What is the method will be available? Okay, so many free softwares will be available. You don't bother much about the coordinates value, so it will be give the coordinates value for the corresponding aerofoil. Okay, apart from that, you want to know how the aerofoil coordinates are generated. Is purely based on the equations. Okay, so in these lectures, finally I have given the example for 4 series aerofoil equations. Okay, again they are also following some steps, nearly 3 or 4 steps. So based on the steps, you will be able to get the aerofoil coordinates value. So all these things will be discussed in this video. The first one we are starting with aerofoil nomenclature. So this is the aerofoil. The aerofoil may have so many types. Mainly we are calling about the symmetrical aerofoil or cambered aerofoil. So cambered aerofoil or asymmetrical aerofoil, both are same. So symmetrical aerofoil or cambered aerofoil. Okay, so here I am showing the cambered aerofoil. The next slide you will come to know the difference between symmetrical and cambered aerofoil, because when you are taking the cambered aerofoil, it is easy to giving the details about the aerofoil. That is why I taken for the cambered aerofoil. Okay, so we will see one by one what are the terms involved for the aerofoil. The first one, this dotted line. This dotted line is called as a mean camber line. The function of this line exactly divide the aerofoil into two equal parts, whether it is symmetrical aerofoil or cambered aerofoil. The main function of this mean camber line is exactly divide the aerofoil into two equal parts. Okay, so most of the parameter will depends upon the mean camber line. Okay, that's the first point. So mean camber line. Okay, then second one, this is the point, the leading edge. The leading edge is the most forward point of an aerofoil or most forward point of a mean camber line. So this is the point is called as the leading edge. Similar way, this is called as a trailing edge. The most backward point of the aerofoil or most backward point of your mean camber line is called as trailing edge. Okay, then another point is called as a chord line. The chord line, you can see the thicker line, this thicker straight line. Okay, the line joining exactly leading edge and trailing edge is called as chord line. This is a straight line. Okay, the main camber line may have a curved form of the line, but the chord line is always straight line. The straight line, the connecting the leading edge and trailing edge is called as chord line. Okay, and then similarly the same, the distance between leading edge and trailing edge is called as chord. See here, chord. The distance between leading edge and trailing edge is called as chord. Okay, then another important thing is camber. The camber is nothing but the distance between mean camber line and chord line. The distance between mean camber line and chord line is called as camber, because the cambered aerofoil depends upon this value only. So you have to make very clear, the distance between mean camber line and chord line is called as camber. Okay, and another one, these are upper surfaces of the aerofoil, this is the lower surface of the aerofoil. Okay, so the distance between upper surfaces and the lower surfaces is called as a thickness of an aerofoil. Okay, how we can define the thickness? The thickness is nothing but the distance between the upper surfaces and the lower surfaces. It is exactly measured perpendicular to the chord line. Okay, the thickness will be measured based on the perpendicular distance between the chord line. Okay, so the distance upper and lower surface is called as thickness. So again I want to show another one or two slides to make familiar with the aerofoil nomenclatures. Okay, so first we come here. So I told you in the previous slide we have the two type of aerofoil. Okay, apart from that application point of view we have so many types. So mainly the aerofoil comes under symmetrical aerofoil or cambered aerofoil. Okay, the previous slide I told you this is a cambered aerofoil. Okay, so now we can see this is symmetrical aerofoil. The symmetrical aerofoil we can see only the straight line. So as of now we are saying this only for the chord line. Okay, so what about the camber line, mean camber line? Okay, here the mean camber line, the purpose of mean camber line to make aerofoil into make two equal parts. Okay, since it is a symmetrical aerofoil, the mean camber line and chord line both are in the same line. And that is why you can see zero camber. There is no any distance between camber line and chord line, so that is why it is called as a zero camber. So this type of aerofoil is called as symmetrical aerofoil. So symmetrical aerofoil, camber line and chord line both are in the same line. Okay, so these two are the example of cambered aerofoil or asymmetrical aerofoil. Okay, cambered aerofoil or asymmetrical aerofoil depends upon the position of the camber, mean camber line. We can say this is a positive camber, this one is negative camber. Okay, so you can see the previous we have taken for this type of the aerofoil. So this is, we can say this is for positive camber aerofoil. See here, so this is my leading edge, you know, this is the trailing edge. Okay, and the line joining between the leading edge and trailing edge is called as a chord line. Okay, then line exactly divide aerofoil into two portion is called as your camber line. Okay, the camber line, the position of the mean camber line above the chord line, that is called as your positive camber aerofoil. Okay, the camber line above the chord line, this is called your positive cambered aerofoil. Okay, see another diagram. So here you can see the position of your mean camber line below your chord line. So the mean camber line, the purpose to make aerofoil into two equal divide parts. Okay, to divide the aerofoil into two equal parts. Okay, so the position of your mean camber line below the chord line, so that is called negative camber. So now we can compare the previous line. So we are taken for the positive camber aerofoil. So this is cambered aerofoil, especially positive, because your mean camber line above the chord line. So this is positive cambered aerofoil, this one is negative cambered aerofoil. Okay, so this is a basic idea you must be know. So for symmetrical aerofoil and campered or asymmetrical aerofoil. Okay, so here again you come to this picture. Okay, I want to add another one more terms, that is called zero lift line, the point number 1. The point number 1, zero lift line, the point 1 having a zero lift line. So you are familiar with the chord line and the camper line. Chord line nothing but the line joining between leading edge and the trailing edge, and camper line exactly divide the aerofoil into two equal parts. Then what is the meaning of zero lift line? So zero lift line is nothing but you see the position of your symmetrical aerofoil and the campered aerofoil. So this may be our free stream velocity. V infinity refers the free stream velocity. Okay, so when I am having the free stream velocity like this, okay, in the symmetrical aerofoil, if the new term angle of attack. So angle of attack is nothing but the angle between main camper line, this is our chord line, and free stream velocity line. So angle of attack nothing but the angle between chord line and free stream velocity line. So here this is case your chord line and mean free stream velocity line both are in the same line, so the angle will be zero angle of attack. Okay, that is why your maybe in this cases lift value will be 0. For symmetrical aerofoil, 0 angle of attack, the lift value will be 0. But the same condition here, this is my chord line, okay, and this is my free stream velocity line. So the chord line and free stream velocity line, okay, even though it is a no angle of attack, that is both the chord line and the free stream velocity line are the same line, so the angle of attack is 0, it produces some lift value. Okay, so suppose I am using campered aerofoil for my design, but I don't want the lift value. So what I can do, I have to tilt my campered aerofoil somewhat in negative angle of attack. Negative angle of attack means I have to tilt my aerofoil somewhat downward direction. Okay, then only I can able to get zero lift. Okay, so the same way here the zero lift line it refers, okay, the line, it's an imaginary line. When you are positioning the campered aerofoil at zero lift line, you are getting zero lift value. That is the meaning of your zero lift line. Okay, see here in this picture, this is my free stream velocity line, and this is my chord line. See here, this is my chord line because the line is joining between leading edge and trailing edge. This is my chord line and this is my free stream velocity line. Okay, the angle between free stream velocity line and the chord line is called as angle of attack alpha. This is called geometric angle of attack alpha. Okay, suppose if I am having like this, I have the lift value. I want to make my aerofoil will be zero lift for the campered aerofoil. Okay, then I have to make this line should be exactly horizontal, because this is my zero lift line angle. Okay, suppose this zero lift line will be located in the exactly horizontal, that means the campered aerofoil have somewhat tilted, automatically my lift value will be 0. Okay, so that is why we must know the value of zero lift line. So that is the meaning of your first point, zero lift line. And second one for your leading edge. The remaining are you are very familiar, we are discussing so many times. So the second point will be leading edge, and third point no circle, because we are having the leading edge. So leading edge may having a some radius. So how we are going to identify the radius? By using of the circle. So that is why we need to know how the circle will be formed. That is why the third point will be no circle. Then fourth one, the maximum thickness. So maximum thickness of an aerofoil. And fifth one is camper. The camper is nothing but the distance between chord line and the main camper line. The sixth one will be upper surfaces, seventh one will be trailing edge, and eighth one will be mean camper line, and ninth one will be lower surfaces. So these are all your familiar terms. Okay, so in this picture you have to know what is the meaning of zero lift line. Again, some more important terms. Okay, so you have the idea, the camper is nothing but the distance between the main camper line and the chord line. So here we must be know the location of the camper. See here, F denote the camper value. So F denote this picture, F denotes the camper. Camper is nothing but the distance between the main camper line and the chord line. Okay, so because while you listen the NACA numbering systems, we must be understand the term location of your camper value. So this is my camper. Okay, this is the maximum camper. the location of the maximum camper from the leading edge, so in the direction of x. That is why the symbol xcf. So xcf is nothing but location of your maximum camper in the aerofoil. Okay, similar way, this is a thickness. So this is a maximum thickness available in the particular aerofoil. Okay, so we have to locate the location of the maximum thickness from the leading edge. Okay, so whenever your terms, the position comes, we are taking the reference of only leading edge only, not trailing edge. Okay, so we are taking the leading edge as a reference points. From the leading edge, what is the distance of your maximum, location of your maximum thickness. Okay, the thickness is nothing but the distance between the lower surfaces and the upper surfaces. So you can see here also you can say my thickness, here also you can say the thickness, because here also you have the upper surface and lower surface distance. But the main thing is when you are where, at what location you are getting the maximum thickness. Okay, that location we are going to identify in the terms of the coordinates, that's the x coordinates. So x, as usual, x will be the horizontal and y will be the vertical. Okay, so xt refers location of your maximum thickness of an aerofoil. Similarly, the xcf refers location of your maximum camper of an aerofoil, and similarly c nothing but your chord length of an aerofoil. Okay, the same way this picture also will open the same way. Here the f, the location f is nothing but the camper. Then similarly xf, location of the camper from the leading edge. Here is t. Okay, then xt nothing but your location of your thickness from the leading edge. Then here we suppose I want to find the coordinates. Okay, you have to refer this picture. We need to draw the tangent to the mean camper line. We need to draw the tangent to the mean camper line. Okay, then after that, as usual, by using the Pythagoras principle, we can take sin theta, cos theta, then we can able to find out the values. Okay, you don't bother about the tables. Just I want to give the idea about how to draw the tangent to the mean camper line. So you have to draw the mean camper line from the leading edge. Similarly, tangent to the mean camper line from the trailing edge. Then we have to using the Pythagoras principle. Then we can able to find out sin theta, cos theta, because from this only we are going to manually identify the coordinates value. So for that purpose, we have to know this theta values. Now come to the numbering systems. Numbering systems, the 4-digit system and 5-digit systems. These 2-digit system only they are called as digits. After that they are called as a series. So this is a very famous numbering system, NACA 4 digits. That means this involve 4 digits. Okay, that is why it is called as a 4-digit system. So we take the example of 2451. So 2451 contained 4 digits. So each and every digits indicates some meaning. So we will see one by one what is the meaning of each and every digits. Okay, so first you will do the description, and with the example you can able to identify the values. So you see here the first digits. The first digits specify the maximum camper in percentage of the card. Okay, so you know the meaning of the camper. Camper is nothing but the distance between the main camper line and the card line. So that is the meaning of the camper. Okay, so first you have to identify the value of the camper. So what is the value of the camper for the particular aerofoil? So that will be the first position. The first digit indicate the maximum camper in the percentage of the card. Okay, because here we need some reference point. Reference point we are taken as a card. With respect to the card, what is the maximum value of the camper? Okay, so that is the importance of NACA series, because the NACA series most of the parameter they are taken with the reference of your card only. So from the card we are calculating based on the card how much percentage it will be involved. Okay, that is why the first digit indicate the maximum camper. Then second digit. So second digit indicate the position of the maximum camper. Okay, so the previously we discussed here. So our cases, see here, this is the first digit. This is my maximum camper, and this is my position of your maximum camper. That is what they are saying, like to say. Okay, first one is maximum camper available in this particular value. So this is a value of maximum camper, and this one is position of your maximum camper. Okay, that is what they are like to say. Okay, again come to here. So the first digit specify the maximum camper value, so let us using M, and second digit indicate the position of the maximum camper P in the 10th of the card, and last two digits provide the maximum thickness of an aerofoil T, okay, in the percentage of card. So this is the meaning of individual digits, okay. So we can take the example of 2415. You can see one by one. The first digits maximum camper, the value of the maximum camper, that is a 2% of the card. See here the percentage of the card, okay. There is 2%, nothing but 2 divided by 100, automatically 0.02. So you have to multiply with the card value. So maximum camper value will be 2% of the card, okay. So now we have to go for next digit, that is location of the camper. Now we have the camper value and where it is to be located. So that is the second digit. That is the meaning of see here the second digit indicate the position of the maximum camper. That is why using the P, okay. Maximum camper M, okay. Position is P. That is why you use it for the letter P. The 10th of the card. So that is why the 10th means second digit is 4. 10th means 40, okay. So 1 or 10th means 40, okay. That means the 40% of the card. So 40% of the card from the leading edge. So from the leading edge, it's a location of your maximum camper, okay. The 2% will be the camper value, and 4 denotes the 40% from the leading edge. From the leading edge will be the position of your maximum camper. So see here located 40% back from the aerofoil leading edge, that is 40 divided by 100, it gives 0.4. With this C means card value, okay. You have to multiply with the card value, that is your location of your maximum camper. And the last two digits, okay, last two digit indicate the thickness of an aerofoil. See here last two digit provide the maximum thickness of an aerofoil. The thickness that is called as a T, okay. The percentage of the card, okay, is the 15. So in this case we are taking an example of 2415. The 15 will be the percentage, okay. Automatically the 15% will be the card. So maximum thickness of the aerofoil will be the 15% of the card, okay. So suddenly you may have the doubt. So the first digit indicate the maximum value, then second digit indicate the position of the maximum value of the camper, and last two digit indicate the maximum thickness of your aerofoil. Then the next question, what may be the position? In these cases the 4 digits they are not mentioning about the position of the maximum thickness of an aerofoil. So by default the 30% from the leading edge will be the position of your thickness of an aerofoil by default, okay. Whether it is symmetrical aerofoil, campered aerofoil, okay. The thickness will be your position of the maximum thickness from the 30% of your from the leading edge, okay. If they want to make any changes, automatically they are choosing for the next level of numbering system. That is why so many numbering systems are available, okay. So these are the point you have to remember. Suppose if the first two digits 00 means automatically there is no camper, there is no need of location of the camper, that denotes symmetrical aerofoil, okay. That you have to understand here, okay. So here the 2 available, 4 available. The 2 denotes maximum camper value, 4 denotes location of your maximum camper. Instead of 2 and 4, if you have the 00, no camper, if there is no camper, no need of location of the camper. So the type of aerofoil we can able to say symmetrical aerofoil. So by seeing the numbering itself we can able to say whether the aerofoil will be symmetrical aerofoil or campered aerofoil. If it is 00 starts, automatically symmetrical aerofoil, okay. So just I want to give the detail about the 4 digits, that should have taken some time. So if you are understanding the 4 digits, the remaining will be almost the same. There is a only small modification, okay. So that will be the helpful for identify the other type of numbering systems. So now we will see the NACA 5-digit series, okay. The NACA 5-digit series uses the same thickness forms as for the 4-digit series, but the main camper line is defined differently, okay, and the naming convention is to a bit more complex compared to the 4 digits. Okay, so in the case of the 5 digits, so we have taken the example of the 5 digit for NACA 23012. We are taking the example of NACA 23012. The first digits when multiplied by 3 by 2, I am taking the example of 2, when it is multiplied by 3 by 2, it yields the design lift coefficient value. Okay, so by directly can able to find the lift coefficient value for the particular 5 digit series. Okay, in 10th. Similarly for next 2 digits, but nothing but your 30. So next 2 digits, when it is divided by 2, it gives the position of your maximum camper in the 10th of the card. Okay, so first one gives the lift coefficient value, and second 2 digit divided by 2, it gives the position of your maximum camper, and final 2 digits again indicate the maximum thickness in percentage of the card. Okay, that is the meaning of each and every digits available in the 5 digit series. Okay, see here, for example, the NACA 23012 has a design lift coefficient of 0.3. Okay, I am taking the 2, I am taking first digit 2. So what they are saying, the first digits multiplied by 3 by 2. Okay, 3 by 2 means automatically 3 by 2 into 2, 2 to get cancelled, only 3 will be available. You see here in the 10th, that means 0.3. Okay, so 10 divided by 100, you multiply with card value, automatically the 0.3, the lift coefficient value will be 0.3, and the maximum camper located by 15%. How it comes? It says that the next 2 digit divided by 2. So what is the next 2 digit? 30. So 30 will be the another next 2 digit. So the 30 will be divided by 2, automatically 30 by 2 is 15. The 15 will be giving for your maximum camper in 10th percentage. That is why you are getting the location of your maximum camper from the leading edge 15% of the card. Okay, then last 2 digit indicate the thickness, that is simply a 12%. So 12% will be the thickness of your airfoil. The same way the 4 digit and 5 digit, they are not giving the location of your thickness. By default it will be 30% from the leading edge, that we have to remember. Okay, the next one, the modified NACA 4 and 5 digits. Okay, even though we have the clear idea about 4 and 5 digit, they want to make some more modification the 4 or 5 digits. Okay, that is why they taken for this series. So the exam we are taken for NACA 0003. Okay, this is exam you are going to take. So by default you can able to identify 4 digit means there is no any camper value. Similar, there is no any position of the camper. Okay, automatically is a symmetrical aerofoil. Okay, so we are making some modification in this aerofoil. We are taking the aerofoil basically NACA 003 is a symmetrical aerofoil, because first digit 0, another 2 digit also 0, no camper, no need of position of the camper, so automatically it is a symmetrical aerofoil. So here we are going to make some modification. What is the modification? See here 003 is the original aerofoil numbering. We are making some modification. .46 -64.069. This is the modification we are doing in the 4 digit series. Okay, so originally it only for the 4 digits. So after 4 digit .46 and -64.069 we are making a modification. So why they are making the modification? So we will discuss one by one. Okay, so let us consider the NACA 003.46 -64.069 as an example. The basic shape of the 003 as 3% thick aerofoil with a 0% camper. This shape is a symmetrical aerofoil that is identified above the below and the main camper line. Okay, in these cases the first modification we will consider in the 003.64. okay, the first digits following the dashed line refers to the rounderness of the nose. I told you the symmetrical aerofoil or campered aerofoil, the leading edge will be based on the circle. Okay, so that is a rounderness will be depends upon provided by the this after the 4 digit 0.64. okay, that is the meaning of your first digit. Okay, the value of 6 here, the value of 6 indicates that the nose radius is the same as the original aerofoil, while the value of 0 indicate the sharp leading edge, because sharp leading edge symmetrical aerofoil. Okay, sharp leading edge, because symmetrical aerofoil is 0. Sharp leading edge, increasing this value specifies an increasing more rounder nose. Okay, that is the meaning of your the first octet dot 64. The second one, the second digit determines the location of your maximum thickness in the 10th of the car. The second digits determines the location of your maximum thickness the 10th of the car. The details location for all 4 and 5 digit airfoil, the 30%, that what we discussed, I told in the few slides. Okay, 30% from the leading edge. Okay, so in this example, the location of maximum thickness has been moved back to 40%, not 30%, 40%. They are making changes. That is why the 4 are arrived in this modification. The 6 denotes, okay, the radiusness values. Okay, the 4 denotes location of the thickness. The location of thickness not in the 30% from the car, they are moved to the 40%. So this modification they done for the parent value of the numbering system 003.64. Okay, now come here. The finally notice that 00346 -64.00069, this features 2 set of digital proceed by the decimals. Okay, what is meaning? So these merely indicate slight adjustment to the maximum thickness, height adjustment to the maximum thickness and location. Therefore, instead of being 3% thickness, this aerofoil 3.46 a thickness value. Okay, 3.46, the thickness are added, 0.46 level is added. That is why we are getting the 003.46. that's a thickness changes. Then similarly, the maximum thickness location not exactly 40%, okay, the 40 along with 0.46. So that is a change that they are made for the location of your maximum thickness. Okay, that is why even though a small changes we need to mention in the numbering systems, then only when others are seeing the numbering system they can able to easily identify the changes. So these are the changes they are done for the 4 and 5 series aerofoil numbering systems. Then next one is NACA 1 series or 16 series. So 1 series means you don't think only 1 digits are available. It's not like that. Okay, they called only the 4 and 5 digits are numbering system. After that they are using the series. Okay, so NACA 1 series means they started with number 1. Sometimes it is called as 16 series also. So that we are taking the example of 5 digit number. Okay, the 5 digit number, but it started with 1. So we will see one by one what they are meaning for the each and every digits. Okay, the basic. Similarly, you must be know why they are developing this type of the series systems. Okay, the basic concept behind this design approaches is to specify the desired pressure distribution over the aerofoil. Okay, I want to mention the pressure distribution over the aerofoil. Okay, because the help of the pressure distribution I can able to find out my lift characteristics value. So for that purpose they have developed the 16 series. Okay, so this distribution dictate the lift characteristic of the shape and then derive the geometrical shape that produces the pressure distribution. That is why they are developed for the your 16 series. Okay, the 1 series or 16 series aerofoils are identified by the 5 digits. For example of NACA 16212. Okay, see here, this is a 5 digit exactly, but the hyphen will be available. That is why it is different from your 5 digits. So in previously 5 digit there is no any hyphen, continuously 5 digit comes. So when the hyphen comes, you have to remember this may be called as either 1 series or 16 series. Even though it is 5 digits, we call it as the 16 series or 1 digits because we are identified with the hyphen. Okay, now we will see one by one what is the meaning of each and every digits. The first digits in 1 indicate the series number because it belongs to series number for the aerofoil. That is why it denotes 1 series. This type of aerofoil is mostly used for the supersonic flow condition. Then the next second digit 6. The 6 specifies the location of minimum pressure in 10th of the chord, that is 60% back from the leading edge in this case. That is a location of your minimum pressure. Okay, that is a location for your minimum pressure for the value 6 denotes. The following dash, the first digits indicate the design lift coefficient in 10th. See here, the after the that hyphen, you see the line 2. So number 2, it defines the design lift coefficient in tenth. That means 0.2 lift value. Okay, that is we can able to identify by using of numbering system alone. Similarly, on the final 2 digits specify the maximum thickness in tenth of the card. So maximum thickness in tenth of the card, as usual 12% of your maximum thickness. Again the same, the position of maximum thickness will be the 30%. If it is changes, it will be mentioned in the numbering systems. The another one, NACA 6 series. Okay, NACA 6 series. Okay, the main goal of these approaches was to design aerofoil that maximize the region over which the airflow remain laminar. Okay, the previous modification will helpful to find out the lift coefficient value, and this series will be helpful to find out the airfoil remain laminar. So I want to make the flow will be laminar. That type of cases I can use the 6 series aerofoil. Okay, in so doing, the drag over the small ranges of the lift coefficient can be substantially reduced. I want to reduce because when the flow will be attached to the body, automatically when it's laminar flow, the drag will be reduced. So the type of the application you can use the NACA 6 series. Okay, the naming convention of the 6 series is by far the most confusing because the 6 series have so many different methods will be available. Okay, that is why they are saying that somewhat confusing. Okay, so in these cases they are taken for the one example, that is for NACA 641-212. Okay, the previously we saw 64-212, the same example. Then how it is called as 6 series, started with 6, the same way the subscript number 1, that also comes. Okay, started with 6, similarly the subscript number 1 it comes. This is a difference between these cases. Here you have to remember the A value equal to 0.6 because A value will be very important. Depends upon the A value only the thickness are to be located. So we will see one by one how the meaning of each and every digits are explained. In the example, the 6 denotes the series and indicate this family is designed for the greater laminar flow. The previously 1 series for lift coefficient, identify the lift coefficient. The 6 series used for the greater laminar flow. Okay, that is why they called as a 6 series. Okay, then the second digits 4 indicate the location of the minimum pressure in tenth of the card, like a previous case. Okay, then similarly the subscript 1, it indicate the low drag is maintained at the lift coefficient. Okay, the point 1 means the point 1, the lift coefficient are maintained at low drag value. Okay, above and below the design lift coefficient, that is point 2. Okay, because you know the point 2 refers your lift coefficient, that what we discussed in the previous numbering system, specified by the first digit after the dash line in the 10th. That is what we discussed in the previous case. Okay, the first 2 digit specify the thickness. The first two digit specify the thickness in percentage of the card, the 12%. Okay, 12%. The fraction specified by the A, because here we mentioned A equal to 0.6. Suppose, that is why I am putting the dash here. Suppose A is not mentioned, you can take A value equal to 1. Okay, suppose A is not mentioned, you can take A value to mention, you can take A value equal to 1. Here A value is given for 0.6. Okay, that is why the dash is given. Okay, so now we can read it. The fraction specified by the A equal to 0.6 indicates the percentage of the aerofoil card over which the pressure distribution on the aerofoil is uniform. That is, here you mention is 0.6, that is 60%. Okay, suppose if the value is not mentioned, you can take as a 1. That is what the numbering systems are saying to us. Okay, if the A value is mentioned, you can take the particular value, otherwise you can consider A value will be 1 for the particular cases. The next one, NACA 7 series. The NACA 7 series, the 7 series was further attempted to maximize the region of laminar flow over an aerofoil, differentiating the location of the minimum pressure on the upper and lower surfaces. Okay, here we are taking the example of these particular cases, 747A315. This example we are going to consider for explaining the numbering systems. Okay, the 7 denote the series, then 4 provide the location of your minimum pressure on the upper surfaces in the 10th of the card, that is a 40% of the card. Okay, then and third letter 7, the 7 provides the location of the minimum pressure on the lower surfaces in 10th of the card. Okay, so that is upper surfaces, here lower surfaces. You have to identify carefully. The second digit indicate the upper surfaces, and this third digit indicate the lower surfaces of the your location. Okay, then the fourth digits, A, letter A. Okay, it indicate the thickness distribution and mean line form used the A series or standard form, because there are so many series will be available. Okay, they are, in this case they are following for the A series, that is what they are mentioning for the fourth digits. Okay, forms, okay, derived from the earlier families, and designing the different letters, maybe A or some other will be available. Okay, again the fifth digits, indicates the design lift coefficient in 10th. Okay, the fifth digit we see 3, that is a 10th of the lift coefficient. And the final two digits as usual indicate the aerofoil thickness in percentage of the card. Okay, that is what a numbering system. In all the numbering system, the last two digits indicate the thickness of an aerofoil. So now we come for the last series, NACA 8 series. It's a last series. Okay, each and every series having a unique importance for choosing of the aerofoil. Okay, in these cases the goal was to maximize the extent of laminar flow on the upper and lower surfaces. Okay, so independently the naming convention is very similar to the 7 series. That is why we have taken the example of this particular NACA numbering systems, NACA 835A 216. This is 8 series will be taken. Okay, we see one by one what is the meaning of the individual letters. The 8 designates the series. Okay, the 3 in the location of the number second digit. The 3 is the location of the minimum pressure on the upper surfaces in the 10th of the car. Okay, minimum pressure on the upper surfaces. Okay, then 5 is the location of the minimum pressure on the lower surface in the 10th of the car, as usual, like a previous case. Okay, then the letter A denotes the aerofoil having a different camber or thickness forms. There are so many series, so here we are taking for the A series. That means aerofoil having a different camber or thickness forms. Okay, then 2 denotes the design lift coefficient in the 10th. Design lift coefficient value we can able to find out directly. And last 2 digits 16 is provide the aerofoil thickness in percentage of the card, as usual like a previous case. So in all the cases last 2 digits indicate your previous thickness of your aerofoil. Here I want to give some idea. So far we are discussing about aerofoil numbering system, starting with 4 digit, 5 digits, and 1 series, 6 series, 7 series, and 8 series. Okay, you may have so many thought. Okay, how I can able to choose my aerofoil? That is very important, because once you are understanding the meaning of the numbering systems, then we have to implement the idea when and at what condition I can able to choose my aerofoil or apply my aerofoil. Here I am given some idea in the form of tabular column. Okay, for the particular, if you are choosing 4 digit aerofoil, some advantages will be there, similarly some disadvantages will be there. You have to consider the advantages. This is your requirement. Okay, and similar way some applications in the previously applied applications also will be given here. Okay, so you can get idea, because suppose I want to my lift coefficient will be very low, then I can choose my 4 digit aerofoil. Okay, and similarly my stall characteristic should be very good. That means I have my maximum lift, maximum angle of attack I need to achieve. It means I can go for this 4 digit condition. Like that you can read it. It's like a self study. It depends upon the independent requirement we can choose aerofoil. So that is what I given this tabular column. Okay, and the 4 digits and 5 digits aerofoil advantages, disadvantages, and application point of view. And similarly this is for your 1 or 16 series, and 6 series, 7 series, and 8 series. So you know very well 8 series is very rarely used. That is why the data is not available much in the net. So if you have any data, so kindly post me in the comment section. Okay, I will also come to know so about your 8 series. Okay, these are the advantages and disadvantages of your aerofoils and application point of view. Then I told you in the very first slide, I will give the idea about how to identify or generate the coordinate for the particular aerofoil. So in these cases I am taking the very primary or basic condition, the 4 digits aerofoil. Okay, the 4 digit aerofoil, we have to follow these 4 steps. Okay, the first step we have to identify the value of x. X will nothing but your 0 from C, 0, you know, 0 starting of leading edge you consider as a 0 and ending with the trailing edge you call it as a chordate, that is C. So you have to choose the value of x from 0 to chord value. That's the first step. And second step, we have to define your mean camper line. So mean camper line define in terms of y coordinates. Okay, x value in the chord line, mean camper line defined by the terms of your y coordinates. Okay, when you are discussing with the y coordinates, we have the apply for the 2 condition, because the camper line only depends upon the y coordinates. We have to identify the maximum camper and location of the maximum camper. These 2 points we have to remember. So maximum camper and location of the maximum camper, the position of your maximum camper. That is why when you are designing your main camper line, you have to follow these 2 formula. So the first formula will be applicable up to 0 to position of your maximum camper. Okay, 0 to position of your maximum camper. Okay, like starting from 0 to position of your maximum camper. Okay, then second, this equation will be applicable to from the position of your maximum camper to the trailing edge. Okay, here you can see 0 means leading edge. So leading edge to maximum position of the camper. Then this one from the maximum position of the camper to trailing edge. For I want to identify the coordinate for the particular case, you have to go for this particular equation. Okay, so you know the meaning of x, the value of x, and p the position, and m nothing but maximum camper. All those things we discuss in the 4th digit itself, so that we have to identify. So this equation will be helpful for locating of your mean camper length. This is for second step. And third step here, the explanation will be given for in the same of sentence. The third step, you have to identify the third point, thickness distribution. So see here the thickness distribution. So thickness distribution, it may be in the positive way as well as negative way. The thickness distribution, that is why you have to use this equation for your thickness, aerofoil thickness distribution. Okay, plus or minus. So the thickness distribution, that is why you use the symbol T. So thickness distribution also in the y coordinates, that's why yt. Okay, so when you are using the positive value, you get the upper surface thickness. When you are using negative value, you will get the lower surface thickness. So this is the equation for using the finding or coordinate value for the thickness. And the last step for your upper and lower aerofoil, x values. Okay, x values. Here you are using for the y values, here you are using for the x values. So for upper and lower value x values, you have to use the theta value. That is why the starting the slide I show you, you have to draw the tangent to the mean camper line. From the tangent, by using a Pythagoras principle, you have to find out to sin theta, cos theta, and tan theta. So these are the procedures, especially for the 4 steps you need to follow for identifying or generating for the particular aerofoil. So these equations applicable only for the 4-digit series. Suppose you want to use 5-digit series or 7-8 series, means you have to go for the corresponding aerofoil series equations, because so many series of equations will be available. So these equations are only applicable for 4 digits. So you want to go for 5 digits or 16 or 8, 7 or 8 series, you can refer the any other sources, there the equations will be available. Okay, it's only for the numbering system, that is why I am not taking for that particular set of equations. Okay, so these are the things I want to convey to you. Yes, we are coming for the last conclusion slide. So I must be thanks to Anderson similarly for some web sources. I am taking so many data from these are the reference areas, especially Wikipedia and other reference material from the other sources I have taken. Based on that only I prepared for this presentation. I hope maybe the lengthy video, but I tried to cover the full detail about NACA numbering systems and related to aerofoil problems, because since we are the aeronautic engineer, we should not get any doubt or any problem with, especially for dealing with the aerofoil. That is why I made this video. Okay, once again, thank you. So thank you for watching this video. So once again.